Visual snow is a labyrinth offering the person submerged within its walls a never-ending journey. It is a framework to tell yourself stories about yourself. Illness, neurodiversity, magic, sci-fi, all are possible mythic palettes from which to paint the colours of your own story. It is a patina, rough and raw, scratched across your eyelids that reveals your individuality. A mark, it says, this is what the brain is and how it works. Welcome to the Distorted Constellations Salon. Times, intimacy, touch, tingles. This evening is the beginning of the end of Distorted Constellations. A ritual, mythopoetic, neurophenomenological space. And tonight, into this space, we pour ourselves. Welcome to my brain, welcome to my nighttime, welcome to my all night, not sleep, not dream, not wake, conversations with those who can't speak back. My name is Nwando, Ebizie. My sign name is the gesture protection. I'm the artist curator of this space. You're all very welcome. You can feel free to be in this space. You may be touched. It's okay to say no to touch. You may be invited to touch other things. It's okay not to. I'd like to introduce my two special guests for tonight. First of all, we have Joe Muggs. Joe is a culture writer who writes for The Guardian and Fact and The Wire, and he's just created an amazing book about bass culture called Bass Mids Tops. Joe is neurodivergent and has his own unique way of experiencing reality, and from this he has created a life writing about creation.
Yeah, I have spent my life writing things down. As we were discussing this earlier, and it's only really recently in my life I realised why I write so much stuff down. Part of that is because I have no inner imagery. I'm aphantasic. This is not even a thing I discovered existed until recently. I thought when people said they picture something in their mind, it was a metaphor. So it affects the way I remember things. And so I always had to kind of keep notes. I also have always had a difficult time with complex social interactions. I can talk one-on-one to people forever. I can talk with two people. Beyond that, it's more difficult for me. That led me to become obsessed with group social interactions. I only realized this in retrospect, in later life, that the reason that I document social scenes and the mechanics of those social scenes is because I don't understand them.
have here Professor Sophie Scott, cognitive neuroscientist. I first came to know of from my midnight trawlings through podcasts when I couldn't sleep. And one particular podcast, there was a woman who kept on talking about tickling rats.
I'm a brain scientist, and I'm really lucky to get to work with, no offence to the rest of you, but the best bit of, I think, any human is your brain. I absolutely love your brains. And there's nothing else really in nature like your brains. It's easy to take human brains for granted, but the scale of the complexity and their size and the evolutionary journey we've been on to develop them is kind of dizzying. And one of the things I'm particularly interested in is how our brains, what our brain's main job is, and you can think of one of the main jobs of the brain is perception. And you're perceiving two very general kinds of things. You're perceiving the stuff that's out there in the world. So you're perceiving the vision and smell and taste and touch and hearing. But you also perceive the stuff that's coming from your own body. So some of your senses, vestibular sensation, that's to do with balance. Proprioception, that's literally knowing where all the bits of your body are. And of course, your body makes sounds, and you can see your body, so you're also perceiving the things you do, the noises you make. And how your brain actually solves these problems, and how your brain is able to tell what's you and what's something else that's out there in the world, it's an amazing set of problems. It's very, very hard to get a computer to do this or build a robot that can do this, and we learn to do it apparently effortlessly. So I'm very interested in this basic mechanics of how our brains construct everything. So everything you see and everything you hear is your brain's best guess at what's out there. And our brains do solve this problem differently. So a lot of what we mean when we talk about neurodivergency is simply, for want of a better phrase, variation that is, in fact, use a statistical term, just normal variation. There is nothing unusual about it. People just vary a lot on different ways that your brain can solve problems. And then you also have neural complexity in terms of sometimes things are just fundamentally different. So your brain might have some completely different way of doing things that can't easily be compared to how another brain works. So actually, I'd say one of the things we've learnt from having these new techniques at our hands to be able to ask questions about individual healthy brains by looking at them in the scanner is actually how much more interesting complexity there is in terms of as much to do with how much we differ as in how much we are the same.
I created this exhibition to explore my own perceptual reality. I have a neurological disorder called visual snow, but I feel like the more I put on this exhibition and the more I talk to people who have supposedly rare or strange things in their brains, the more I have conversations with people who say, oh, but I also have this weird or strange thing or rare thing. So, Sophie, how different are our brains? Is there such thing as a normal brain?
Well, it's a very good way of putting it. There really is no normal brain. And that's really for two reasons. The first of all is that brains are highly individual. They're like faces. So the same anatomical structures you can find in all brains, but they can look extremely different, just like faces might all contain the same features, but the size, the shape, the exact arrangement can be very, very different. And sometimes that does seem to lead to significant differences. So years ago, I did a study with phoneticians, people who are very, very good at listening to speech sounds and kind of analysing other people's voices. And we found they had more complex auditory cortex shapes. So it's just like the shape of their brain, almost certainly what it was born like, has probably affected their whole lives, and almost certainly that's not going to be restricted to phoneticians. I suspect we'll find it if we look at someone like Joe or people that do a lot of work with sound and music. It might just be a way that your brain works that has disposed you to go into a certain area. Human brains develop over your whole lifespan, but they develop particularly quickly in childhood. And in fact, that childhood trajectory of development is not complete until you're in your early 20s. So you've got 20 years or so, where the outcome of the brain you have in your early 20s is going to be because of the things that you've done and the experiences that you've had and what else has gone on in that period. So you could, if you really want to change your brain, you teach someone to read, teach them to play a musical instrument. All these things, these experiences that either opportunities to get to them or to not get to them can really affect how your brain works. And then on top of that, you've got how the, for want of a better phrase, the genetics of what you're coming into the world within your brain and these experiences do when they interact, because that's a really growing area of science. It's not nature versus nurture. What you see is something that actually is a feedback system, and that can really affect how your brains develop. So as soon as you start throwing in something more complex, like real divergence in terms of, for example, how you process social information or how you're dealing with visual information, how you can image things, that won't just be like and my brain also does this. It will have an impact on many other aspects of how your brain is functioning. So what you're seeing is a very complex system, and it's, as I say, it's absolutely dizzying in terms of the complexity. You have something like 86 billion neurons in your brain. It's unbelievable. And how those neurons are talking to each other, how they're connecting, the networks that you have, these things that are arising out of these properties of sort of development and individual differences.
86 billion neurons in the brain. That's more than the stars there are in the sky? Is that how do you visualize that?
Yeah, it's really quite. It's absolutely. It's sort of unbelievable. And you start to get a glimpse of how incredibly hard it is to. People are always saying, well, no, we've got a new human brain project. We're going to build a brain that simulates. Build a computer that simulates a brain. And you think, well, do you know what? Come back when you've got 100. Let's say 50 billion neurons, but also show me how that brain grows up. Diversity in how human brains work. It's not a bug. It's a feature, and it's what you want in humans. And if you look at humans as a bigger picture, one of the reasons why we've been a very, very successful species is because of the phenomenal flexibility in our behaviour. Humans can cope in all sorts of situations, and we invent things to help us solve problems. And actually, that's because of this complexity of our brains and their ability to learn and to change, and the fact that their brains don't all work the same, so we don't all solve problems the same way. So you've got much more likelihood of solving complex problems with new inventions if everybody is thinking slightly differently.
I'm thinking about interconnectivity and then interconnectivity again. I mean, 50 plus billion neurons, how many connections between them? 50 billion neurons in one brain connecting to 50 billion neurons in another brain, connecting to 50 billion neurons in 20 brains in your group of friends, connecting to 200 brains in a small club, connecting to 20,000 brains in a big club, connecting to 1 million across the world within a subculture that you're part of. And when you start thinking in terms of numbers, you are way beyond the number of atoms in the universe. It's the actual number of connections and the number of possibilities within that is wild. And yet we navigate that as normality when we go out in an evening.